A single snapshot from an amateur can unlock secrets scientists have chased for decades, and you've never seen how. Stay with me until the final entry, because number 1 reveals a discovery that even seasoned researchers missed. Imagine a hidden camera snapping a shy snow leopard that eludes even the most seasoned trackers. These motion-activated traps, placed by hobbyists across remote mountain ranges, capture thousands of frames that researchers sift through to map population densities and movement corridors. Because volunteers can deploy dozens of units at a fraction of the cost of institutional projects, the data pool expands dramatically, revealing breeding hotspots and migration shifts previously invisible. Moreover, the timestamps and location metadata provide precise temporal context, allowing scientists to correlate animal behavior with climate variables. As a result, conservation strategies become more targeted, helping protect endangered species before it's too late. The collaborative spirit of citizen photographers turns each fleeting image into a vital piece of the ecological puzzle.
Surprisingly, a flock of amateur birdwatchers armed with smartphones is charting migration routes across continents. By uploading geotagged photos to shared databases, they create real-time maps that show when and where species like the Arctic tern stop to rest. Researchers then overlay these points with weather patterns, uncovering how shifting wind currents influence migration timing. This crowdsourced data fills gaps left by traditional banding studies, especially in regions where funding is scarce. Over the past few years, the collective effort has identified new stopover sites, prompting the creation of protected areas that safeguard critical habitats. The sheer volume of images, captured during sunrise or dusk, also helps calibrate satellite tracking models, making predictions about future migration changes more accurate.
Few people realize that a simple beach selfie can become a data point in the fight against plastic waste. Volunteers worldwide photograph littered shorelines, uploading their images to platforms that automatically count and classify debris using AI. Scientists then analyze spatial trends, pinpointing hotspots where microplastics accumulate most heavily. This grassroots mapping has revealed unexpected pollution corridors feeding into remote marine ecosystems, prompting targeted cleanup missions. By aggregating millions of photos, researchers can also assess the effectiveness of policy interventions over time, seeing reductions in certain plastic types after bans are enacted. The visual evidence is powerful, turning abstract statistics into compelling stories that drive public awareness and legislative action.
Hidden in countless nighttime panoramas is a record of Earth's growing glow. Enthusiasts capturing star trails from suburban rooftops inadvertently document the spread of artificial lighting. By comparing images taken over years, astronomers quantify how sky brightness encroaches on dark sky reserves, affecting nocturnal wildlife and astronomical observations. This visual dataset, contributed by photographers from every continent, helps model the impact of LED installations and informs city planners on how to mitigate glare. Some communities have already adjusted street lighting based on these citizen-generated insights, restoring clearer skies for both ecosystems and stargazers.
Remarkably, a network of garden lovers photographing blooming roses each spring provides clues about climate change. By timestamping each blossom shot, they create a phenological calendar that tracks when species flower across latitudes. Scientists compare these dates with temperature records, revealing shifts in seasonal cues that affect pollinator interactions. The amassed image series has uncovered that several native wildflowers now bloom weeks earlier than documented a decade ago, signaling subtle but significant ecosystem adjustments. Such data enriches long-term ecological studies, offering a grassroots complement to satellite observations.
Astoundingly, city dwellers sharing photos of raccoons, foxes, and even bobcats on their balconies are reshaping urban ecology research. These candid captures provide occurrence records that map species adaptation to metropolitan environments. Researchers use the geotagged images to identify corridors, like green roofs and riverbanks, that facilitate wildlife movement through concrete jungles. The data also highlights human-wildlife conflict zones, informing mitigation strategies such as wildlife-friendly fencing. By aggregating thousands of such sightings, scientists can model how urban expansion influences animal behavior and distribution, guiding future city planning toward coexistence.
Deep beneath turquoise waters, Scuba enthusiasts snapping vibrant reef scenes contribute to marine health assessments. Their high-resolution photos capture bleaching events, disease spots, and species diversity, which marine biologists later annotate for longitudinal studies. Because professionals can't cover every reef stretch, these volunteer images fill crucial gaps, allowing scientists to track the spread of bleaching across the globe in near real time. The visual evidence also supports climate models predicting future reef conditions, and helps prioritize conservation funding for the most affected sites.
Few people realize that macro photography of garden insects can reveal population trends. Hobbyists photographing bees, butterflies, and beetles upload close-up shots to citizen science portals, where AI counts individuals and identifies species. Over time, these datasets expose declines in pollinator numbers or the emergence of invasive insects in new regions. Researchers cross-reference the visual records with pesticide usage maps, uncovering correlations that inform agricultural policy. The sheer volume of images provides a granular view of insect biodiversity that would be impossible for any single research team to achieve.
Unexpectedly, trekkers capturing the edge of retreating glacier contribute to climate science. By posting repeat photographs from the same viewpoint each summer, they create a visual time series that quantifies ice loss. Scientists calibrate these images with satellite data, refining models of sea level rise. The personal narratives accompanying the photos also raise public awareness, turning abstract climate metrics into tangible, human-scaled stories of change.
Finally, amateur skywatchers filming meteors, eclipses, and auroras provide invaluable observations for astronomers. Their timestamps and precise locations help verify predictions, refine orbital paths, and even discover new fireball trajectories. The collective visual archive expands the temporal coverage of rare events, ensuring that no fleeting phenomenon goes unnoticed by the scientific community.
We've journeyed through 10 astonishing ways everyday photographers are propelling science forward, from tracking elusive animals to mapping the shifting climate. Each story shows that curiosity behind a lens can become a catalyst for real breakthroughs, reminding us that discovery isn't limited to labs. If you loved seeing how ordinary eyes can fuel extraordinary research, hit like and subscribe so you won't miss the next mind-blowing list we drop each week. Which citizen photography contribution surprised you most? Share your thoughts below, I can't wait to read them. Thanks for watching, and keep looking up through that viewfinder.